Hi.
It's unfortunate that spring is right now.
I know.
Because that's a popular one. I would need it myself.
Right. By the way, Mon Kamala, he's presenting here, but he also wants to be in spring. So it says he will come here after they have talked about his in spring. So we have to put him towards the end of the agenda. Yeah, it will be fine. Yeah. So is Adrian is in the back as KD or
No, he's just here.
Yeah. Yeah. I know if Alvaro will be here in spring.
Yeah.
Do you have
I've got all the slides up.
you do?
Yeah. You could do either if you prefer to use yours, but I have all the latest ones.
No, I can use yours then. Yeah. I'm not sure if when I use the provided one.
Yeah, I
Don't
just-
really know how to use it.
I just don't feel comfortable.
Yeah.
But actually, maybe I should try.
So we could try. Oh, that's for the mouse, the remote. Like it's for this. Right, sure. Right. Yeah, I think it's just people might confuse it as a USB drive. Probably. Yeah, already 3 minutes into the meeting. We'll get the minute taker. Yeah. Kind of need to get Jake or Troy or something. But yeah, I can take minutes and finish. If you take minutes when I'm up there. Yeah, that's okay. Yeah, it's not great. But it's not.
We're supposed to start right now, right?
Yeah.
Okay, we're going to go ahead and get started. Thank you for coming. People may filter in. We're competing with spring. Unfortunately, we'll try not to make that conflict next time. But appreciate you being here. We do need thank you for getting that door. We do need a note taker. Our usual people that take notes are not here. Does anybody have interest in taking notes? Minutes? No. Should we just do it this time?
Yeah, I guess we can do this.
We're just going to do it. We're just going to have to take turns and do it ourselves. Plus, we got the videos. We can go back and watch the video if we have to fill in the gaps. All right. So note well, this is our agenda. Should take us most of the time today. If any of that looks incorrect, if we missed you, please say something. Human, I know you have a draft name, but we just didn't update this with your draft name. But yeah, it's there. All right, so Stig, you're going to take all this.
Okay. All right, so we'll try to go through all the working group documents and what their status is. So we have a PIM-Yang model that has been approved and it's been in the RFC editor's queue for half a year maybe. But it's basically waiting on references. There's a lot of other Yang documents that it's waiting on. So there's like a big group of Yang documents that will go in together, be published together as RFCs. We also have IGMP and MLD Yang models that are with the ISG, and there was an IETF last call, and there's some comments and some work on addressing those. We'll have a presentation on that today, I believe. So it's an MSDP Yang model. It did pass last call, and we should probably request publication for that now. There was some question whether there should be a JSON example in there or not. I'm not entirely sure of that. We may have to ask Alvaro or some Yang expert, but we might just request publication and see whether we will be told to add that or not. We got the multiple upstreams document. So that's a little complicated, but basically RAD and the ISG doesn't think it's worth publishing it the way it is now, as we understand it. It's just requirements, and they thought the requirements were maybe not that, not worth publishing. So the authors are asking to publish it as an independent submission. Basically, anyone can, unrelated to working groups, can go ahead and publish a document as an RFC. There's like a separate approval process for those. It doesn't really mean much for us, I think, as a working group. We'll get published a document that had the requirements that we agreed on that we wanted to get published. It's just that it's not officially a working group, a product of the working group. Let's see, next slide. I was trying to change. I can use this, I guess. Yeah. All right. We got the DR load balancing draft. We requested publication for that since last IETF. We got MLD snooping Yang model. Get an update on that today. It might be ready for last call, perhaps. We'll talk about that. The IPv4 prefix or IPv6 next hop, the authors have been very lazy. That means I've been very lazy. I'll try to work on that for next IETF. DR improvement draft, it passed working group last call. There were some editorial comments, and almost all of them were addressed. I had 2 very minor comments. I think we're waiting for one last revision to satisfy those. So yes, Sandy, I think it was revision 7 I commented on, and you said that you would address my comments, but I don't think we have a revision 8 yet.
Yes, I sent an email to you to make sure the new explanation address your question.
Oh, okay.
Yeah, but I haven't submitted the new version.
Okay.
I will do it.
Okay, I'll check my email too. But yeah, it's just that editorial, very minor thing. So once that is done, we'll request publication.
Thank you.
And then we have an explicit tracking draft that is dead, and will probably remain dead unless the authors or someone else decides that they want to work on it. Yeah. Okay. Okay. We also have a draft on reserved bits that will be discussed this meeting, and non-registered packing as well. And there's also a draft on using point-to-multipoint BFD that got adopted since the last meeting, but we're not discussing that today. So I think that's all we working group documents that we have right now. Any questions or comments? Yeah, all right. Yeah, can use this.
Okay. Good afternoon, everyone. I'm Xufeng Liu from Water Networks. I'm here to give a quick update to two documents. This is the first one, the SNOW-PIM model. So we are trying to get some updates to this document, and since last revision, we are addressing few comments because we have another similar young documents, which is IGM-PMRD young model. So we got a lot of comments for that document. So when we review the comments, so we think a lot of comments can be applied to this document also. So we just address those comments in this document also. And some changes particular to the model. So here, there are some types, young types, already been published in some other documents, other models. So the comments is that ask us to reuse those types so that we can share the same type between models. So here are some examples here. Instead of we use our own IP addresses, so we already defined the multicast group address and multicast source address. So we just go ahead to use them. So making them more consistent and more precise. And those are the changes we have done for this document. So we still trying to see if any further comments. If we have any, we'll address them. Otherwise, probably we can go further for the next call. Yeah.
Yeah. All right. Thanks. So, see, we're not too many people here, but have you read this document? Can you raise your hand if you have read this document? Okay, one person. So I wanted to ask if people thought it was ready for last call, but it's a little hard with only one person having read the draft. So unless you have any objections, we plan to do our working group last call on the mailing list in a few weeks. No objections? Right, okay. So do you plan to do some additional revision first, or are we pretty much ready to do last call right now if you want to?
Right, we think pretty much ready. So the comments we saw from other documents already been applied to this one. Mm-hmm. All right, next document, that's a different model. So this is for the proxy. So this is a revision 01. So the revision 00 was presented in Bangkok, I think. And so there are some, we already received some comments to this model, and thanks for those comments. We addressed all the comments so far. So one is that the place where we should augment this one, the model from. So for the model, young models, we have a base model and augmentation model. So we're trying to fit the big structure of the routing protocols, all the protocols together. And so the place, we think it's better for this model to fit. Now there's routing protocols and particular protocol for this one. So, and also there's another comment about the restriction between different models. So let's look at the changes. So used to be, since we were trying to enable or disable the proxy on particular interface without probably put on the interfaces. And but the interface here is it's not a good place because there could be different kind of interfaces. It may or may not be the protocol interfaces. And the current convention is that we have all the protocols grouped together in the place, like the control plane protocols and protocol list of protocols. So we do the same here and move the structure here. We have a list of interface here so that we know which interface we're trying to do the configuration. That's one change. Another change is the restriction between the models. But whenever we have the proxy enabled on the interface, we should be, we need to check the PIM should not be enabled on the same interface. So we add this check. But there are some issues, and so because this is the proxy model, and so to do the check, we have to access the PIM model. So we have this issue. So if we trying to implement the proxy on the system, we may not have the PIM implemented at all. So we had this issue. And yesterday, talked with the young doctors in the NetConf session, the NetMod. So the consensus from them is that so the way we are doing should be okay. So here, even though we don't have the PIM model implemented, we can still import the PIM model and mark them as just import, not implemented. And in that case, we can still do the checking. And they are trying to improve the Yan language in the next revision, so make it more better usable. We can check, see if the particular model is implemented or not implemented. And that's planned. Still being discussed, see if they can be put into the next revision of the Yan language. So we'll see. If we have that feature, then we'll use that later on. But for now, we just do whatever we do here, unless we have objections from the working group. Other than that, so we like to see more comments, and so we can improve the model further. That's it. Thank you.
All right, thanks. So I guess the question is whether we should adopt this as a working group item. Can I ask how many people have read this draft, the IGMP MLD snooping draft? Can you please raise your hand if you read the IGMP MLD snooping draft? Any people read it? A couple of people, 2 people. So now there's been this young model design team working on this, but it looks like there's less vendors that were involved with this one than the other documents.
We are trying to get, seems like, we're getting back the more participants now. So we got people from Cisco, VMware, and Huawei and others. So I think we resume our weekly discussion meeting from now on. So we welcome more participants to the session.
Okay, thanks. So do you have a feeling whether this is something we should work on? Is it useful to have a young model for IGMP MLD snipping? Okay, one person, two, yeah. Yeah. So this has been around for, I think, like maybe 3 IETFs now or so. And at least there's a handful of people that have been working on it. So from a few different vendors, so at least they are interested. So I think maybe we could do an adoption call on the list. Do you have any thoughts on that?
Well, we had 2 people that raised their hands. Do you, of those 2 or anybody else, think that we should adopt this work?
Or at least an adoption call.
Ian Duncan, Sienna. I'm neither a Yang expert or an MLD or IGMP expert, really. I mean, I understand them, and I've worked on implementations of some of them. So I don't feel qualified to say whether the document as it's written is correct, but I think it's work that we should be doing.
Okay, fair enough. Yeah. Well, we appreciate you raising your hand anyway. So, okay, well, we'll make this request on the list. Thank you. And they're working on getting us another microphone.
Yeah. All right, so this draft is about PIM null register packing. The authors couldn't be here, so I'm presenting on their behalf. So this was adopted as a working group item since the last IETF, I think, very recently at least. So most of you remember this, I guess. The idea is simple. In some deployments, you have to send hundreds, even maybe 1,000 null registers every second or something like that, because it's a single message per S, G. And this causes problems if some of those null registers get dropped because of control plane policing or other reasons. And if you miss some of those, you will end up doing data registers, and the load gets even higher on the RP and so on. So based on several issues we've seen with also like Cisco customers, we decided that it would be useful to have a way of sending multiple S, G null registers in a single PIM message. So that is what this draft is about. And in addition to the packing itself, there's also this compatibility check, which basically says that initially you would send the regular registers we have today, but if an RP supports this, it will set a bit in the register stop messages. So that way the first operator can learn that the RP supports this and can change to using this new type of null registers. And yeah, there's some good reasons for doing this. The changes this last time is mainly the PIM message type. There is this draft I'm presenting after this that talks about how to extend the PIM message type space, and this has been changed to make use of that. There's also some anycast RP considerations. Basically, if you do anycast RP, you should make sure that you either enable this new support for this new thing on all the RPs or none of them. Else you might have a first operator that initially registers to one RP and thinks it supports it. Then because it's anycast, it might suddenly send a register to one of the other RPs, which maybe wouldn't support it. So that's just some text explaining that. That's all that happened since last version. Let's see, that's all we have. So I guess the authors would like input on the changes, or would like people to help review the document.
This is Dino. I haven't read the draft. Just wanted to know, I hope the format is exactly like a join prune message. So,
It's not.
So no new code has to be written. You can use existing code.
Right. So basically you're saying that, for instance, you would like to have a group range and a number of sources or something like that. And yeah. Yeah, right. Right, yeah. There's another draft presented later today that also does this type of packing, and that's maybe something to consider for that as well. Right, thanks, that's good input. Yeah, yeah. Any other comments? Yeah. Did we send out the blue sheets?
Anybody send a blue sheet? Okay, let's get blue sheet. Alvaro's just gonna not. So this one says. You can sign out.
This is Dino. So protocols for, what is it called? Protocols for Internet Multicast? IP Multicast. So why isn't the M also stand for MVone? Why hasn't it been combined? And I thought that was something that was supposed to happen.
Yeah, we're not. Thank you for the comment. I don't know if we're going to get into that again, but we did discuss that a lot. Yeah, we decided not to. That there's plenty of work in both working groups.
But we're trying to meet together as much as we can, like in adjacent slots. This time we had a lunch break between those. So. All right. Okay. I think that's it for this document. It's the reserved bits, I think, isn't it? That one. Okay, so this is about PIM reserved bits. It does a couple of things. The main thing, at least what we thought initially, was to document how different reserved bits have been used by different RFCs. There's no place today where you can go and see which bits are used by which RFC. And some of these RFCs should have updated 4601, but they never did. Anyway, this document started out explaining that, but maybe the most important part with this document is extending the PIM type space. So as you see at the bottom here, we have type 13, 14, and 15, and we are proposing taking 4 reserved bits for each of those types and make subtypes similar to what was done for PIM binder before. So what happens is the PIM header type will change from what you see at the top there to the bottom one. So after the type, you have a subtype field that is 4 bits. So we talked about this before too, but just repeating this. So basically, what happens is that if you do this, the new RFCs would not get a single type like type 13 or type 14. They would be assigned, say, type 13.0, 13.1, 13.2, and so on. So this gives us 48 new types instead of the 3 that we have today. Yeah, so this document was adopted, I think, well, kind of recently. I kind of want to move ahead with this and maybe go for last call. So it's been stable for a long time. I don't know anything that needs to be added to it, but please let me know if you have any concerns. And the thing is, we have some new drafts that might need new types soon, and we would like to, use this new subtype space for those drafts.
This is Dino. Do you think you have enough bits where you can assign one type to vendor specific, and then vendors could do things?
I would be kind of hesitant, at least my feeling is I would be kind of hesitant to give them, say, one of those types like 13, 14, or 15, because that will reduce it to like 32 types that we have we use this subtype. But we do have, if we do this, we have 48 types. So we could maybe assign a couple or a few of those 48 types for when they're specific. Yeah, sure. I think we talked about earlier that this draft could just stay around until we needed the type space. There's no urgency publishing this, but given that there are new drafts that we might want to publish in an IETF or two or something, I think it would be good to just get this done, and so other drafts don't have to wait on this. That's my feel, at least. So, any comments on the draft? Do you think it could be ready for last call? I should ask the chairs if they would consider last call on this, or if you want to ask the room.
There's only one left by default. So, who's read the draft? So I see 3 hands, 4 hands. Okay, so of those who think that this draft is ready for working group last call. So 2 of the 4 feel that that's the case.
I think that's 3.
3 of the 4.
That's right.
Okay, all right. So that's a good indicator. We'll take it to the list and see how we'll get response. But you're probably right.
All right, thanks. Yeah, then I got one more presentation. All right, so we published fairly recently an RFC on this PIM flooding protocol. The main purpose for now is source announcements, but it could be used for other stuff. And the way it's defined is the first up router would, every 60 seconds or some configurable time, send a periodic update with all the active S,Gs that it has. Yeah, and the thing is, potentially there could be a big amount of state, and it's kind of unfortunately having to send these updates maybe that often. Also, you kind of want to send them often just in case you miss some triggered update. But if we had some reliable way of doing this, we could send updates much less frequently. You could pretty much only send triggered updates, only rarely do like a full update. So at least the idea in this draft here is we want to try to make PFM reliable, and we're thinking we can maybe use PIM-port for this. So PIM-port, we have reliable transport between PIM neighbors, and these messages are sent hop by hop between neighbors. So that seems fairly easy. So what we're proposing is some new port message types so that we can send not just join prunes, but also send these messages. So we are suggesting that port connections can be established between neighbors according to the existing PIM port RFC. And then we have 2 new message types. One is for sending an PFM update. So we more or less send the update as it is defined in the PFM RFC, but we add a major and a minor sequence number to identify the update. We also have a new message to request an update from a neighbor. So when a TCP connection comes up, you can send this message and say, the latest I have from these originators are these versions. And the neighbor can send all the latest it has that is more recent than what was requested. And also, if you receive a message from a neighbor that has something newer than what you already had, you will update what you stored and you will send what you just got to your neighbors. And there's this major and minor sequence numbers. The idea is that each full update would have like a major number, so 0.0, 1.0, 2.0, and so on. The minor updates would be, say, 2.1, 2.2, which are updates versus, say, version 2.0, that was the full update. And if you get the full update, you can forget, of course, all the previous state you had from that originator. If you don't get the full update, you need to remember the previous full update still, plus all incremental updates since the last full update. I should say, though, that we didn't have time to make this perfect. We can see some issues with how we describe this, and we'll do some more work. It's a little bit like maybe how in OSPF or ISI is how you ensure that everyone has the latest information, except that this is using TCP for reliability. And one of the main issues we have in the current solution perhaps is sequence numbers. We rely on these numbers being always increasing. But if a router restarts, how do you ensure that it can use numbers that are higher than the previous used versions? So you can maybe rely on the clock or something like that, but there's some issues with that. You can maybe need some way of finding out the last version number that is out there in the domain or the network, and then find out, okay, I need to use something larger than that. This is something that has been solved for the IGPs as well, I think. So there's more work to do here. I guess my main question for you is not about adoption or anything, but whether you think it's useful to work in this space. And happy for any feedback, of course.
This is Dino. I don't know if it's not related to this draft, but I was just wondering, and it's kind of off topic, and if you want to tell me to sit down, please do. But is there any requirements to send PIM control messages encrypted? And would you consider adding QUIC to port?
Yeah, so there are people that want to do authentication of PIM messages, but I'm not sure about encryption. And yeah, maybe, okay, this is just me talking as, I don't know, as an individual. We do have PIM port, which has been defined, but I'm not sure if anyone has implemented it. So at least it wouldn't be a top priority to add QUIC, unless that is actually something that, you know, would make it more useful to people.
We had that, Thomas Eckert, we had that discussion a decade back in snooping, when we're doing PIM security, the discussion before the RFC. And I think one of the compromise that we seem to like was to only have authentication but zero encryption, so that you could still see what payload is there, but they would be authenticated. I've never seen that being done, and to the best of my knowledge now, both TLS 1.3 and QUIC are kind of the matter that zero encryption, nobody needs that, so it's not in the profiles. It's one of the things I bitched about in TLS 1.3, so I'm not sure how difficult it would be to use, you know, TLS or QUIC with zero encryption, only authentication. That's what I would love to see.
Another thing I think we need to consider with transport like TCP or QUIC is if you actually want to have like a snooping device that can do, say, like PIM snooping, to actually have connections explicitly terminated at the snooping device or something, instead of having to inspect these kind of packets on the wire.
Yeah, maybe I should ask the more general question is, do you think the performance properties of QUIC merit adding it to port, not just for encryption?
Yeah.
But based on your comments,
yeah. Yeah, I mean, I think it could be fun to look into it. I'm happy to maybe have some discussions, but yeah. All right, I think that's okay. One more comment.
I mean, I obviously like port, so, you know, if we adopt anything new, it would be lovely not to have the new stuff be a reason of not being able to use port, right? So from that perspective, I'd support this here to basically, you know, when people want to start using it. Unfortunately, I feel that there's so little support for port right now that this may be a little bit still not sufficient to have people do port.
Yeah, and there's also a draft presented a little while ago on PIM registers using TCP or port for transport. So I guess we need to see overall how much interest is there in like reliable signaling for PIM, and is port the right solution? Are there things we can do to improve port and so on?
Sorry. Somehow I think we managed to avoid in the last PIM revisions the discussion about, if you do this, across the internet or so, how about your congestion control, right? So we never got into that. And I'm not sure how we would fare today if that would come up. But the obvious answer to those congestion problems, when you do reconvergence and you have a really big burst of things to do, and we know how badly PIM works in general and how interoperable problems are with the buffers, port is the right answer. But I think we have a hard time now elevating it up to really be the recommended solution as opposed to the old datagram PIM.
Right. Yeah. Right. And yeah, we can maybe see if there's some improvements or things we can do to make this work better for PIM. All right. Okay. Thanks.
Good afternoon. I'm Kamna Mishra from Cisco Systems. So we had presented this draft in, I think, two IETF back. It was about backup DR election. So basically, there are a couple of deployments where we are looking for having live traffic, and to select the primary path and secondary path, you could use either RPF vector to make sure they are divergent path, or there are flex algo. There are so many other procedures to do that. So the question comes, how do you elect backup DR? So this draft doesn't propose any new protocol mechanism per se, and so I think I just wanted to go via problem statement again, that if you have a failure in the DR, this guy has to detect new DR election, you build the tree, and then get the traffic. So maybe for some deployment this might be a problem. They don't want any delay in the traffic flow in case of any failures, and for those cases, for faster convergence, this was the draft we proposed. What happened? Okay, so the solution was having backup DR, and now question is, how do you elect the backup DR? So in this draft I had said that rather than doing any protocol signaling for backup DR election, you just do the second best DR as a backup DR and send PIM join and keep dropping the traffic at the backup DR. And finally, when you detect the failure, you have to basically move to the new DR. There were a couple of cases, and feedback which I had got in last IETF was to make it informational rather than standard, because it doesn't define any new procedure. There are a couple of cases which need to be thought through, which, like when new router is coming up, or priority changes. So how we are going to handle that? So I have added text in those areas, but yeah, it would be good to get feedback.
Tolle Secret again. I hope I'm not contradicting anything I might not remember having said last time, but just because there are no new messages, the behavior on the wire does change, right? You are sending out the join, so which would, to me, mean it's actually a protocol extension, and it should be just normal standards track. I mean, I would rather like to call it hot standby, because that's, I think, the typical term that you basically use when you basically have this backup that, is immediately ready to do things. Backup is a little bit too unspecific, but other than that, why not simply standards track? I mean, what was the argument for it? There is change on the wire. You are sending the joins, which you otherwise don't.
Okay, I don't remember what was the argument, but yes, I presented it in 102, and that's when I think there was a feedback from the room that it has to be informational. I don't remember who had made that comment.
So back to the notes, right? If it was me, kind of let me, otherwise let's bring up the discussion again.
Sure.
Because logically, to me, it seems it should be just normative.
Okay.
Because a join being sent when?
Yeah, some comments to Stig here. Yeah, so it does also propose things like, like using DR priority 0 initially, for instance, when you come up and stuff. So it does change the protocol behavior. So I feel like this draft has other important things than just backup DR. For instance, what I just said about hold time of 0, sorry, DR priority 0 initially. So I wonder if the title should be slightly different.
Sure.
Just think about it. I feel like we need some more text to explain how this differs from the DR improvement draft.
Okay.
Why would you use this versus that? Or so the DR improvement draft, which DR improvement, what it does is it uses some new hello options, and it allows you to have kind of like a sticky DR and sticky BDR when there's changes. Which is something that this doesn't do. So it could be good to maybe explain that with a few words.
Jeffrey from Juniper. Did we talk about merging those two drafts?
No.
No?
Well,
Okay.
we did discuss it. I remember we mentioned this in the previous working group, but then you decided that they're
Yeah.
worthwhile to keep them
Yeah.
independent.
Okay. Then should they mention each other just so that the...
Yeah. Yeah, so actually I was thinking, this should mention the DR improvement draft, but we should think about maybe it's worth adding just a little bit of text in DR improvement to just sort of say how it is different from this.
Sure.
We can propose some text on the list to discuss that. Yeah. Also, yeah, reading this draft, I felt like it could need some more text still to explain the behavior of the BDR. Like
Sure.
what are the benefits of electing a BDR and how exactly can a BDR take advantage of that?
Does that improvement draft also support this type of use case? Is it meant to do that, or just?
Yeah. So not sure about the hold time of 0, but at least the whole idea with that too is you elect the BDR, and the BDR can do things like hot standby, as you said, like send join substream and so on.
So we do have then two competing solutions, and
Yeah.
okay. So I need to read two drafts as two RFCs later on as a user and figure out, without having any explicit comparison, which one fits me better by understanding all the protocol details.
Yeah. So
I mean, I'm lame.
Yeah.
I understand as a draft reader I should do it in the IETF, but is that also what we want the end user absorbing RFCs later on to do?
Yeah, so at least one option would have been to merge them. The other option we are saying now is, maybe the two drafts can reference each other and have some brief text explaining, how is this different.
So I think maybe in the list we can get the feedback and then decide. So in fact, during last presentation, the same question was raised, whether we want to have single draft or we want to have both of them, whether it makes sense to have two different kind of solution.
I mean, I completely understand how it's easier to get a lot of small drafts through the IETF, but I mean, ask any poor operator how he kind of tries to get through that maze, right? I think that's always the issue.
Yeah, I think that would be the ideal. And Alvaro, I think that you would agree that that would be the ideal. But working groups do produce competing RFCs, right? I mean, that's something that happens.
Yeah, Alvaro Rotana. Yes, I always prefer less documents because I have to read them all. But yes, I think the important thing is if there are two solutions to the same problem, it needs to be clear why. If it's just that we have two solutions to the same problem and there's no real functional difference, or nothing against this draft, but if the other draft does other things and addresses this use case, maybe that's something that the working group should consider as well. But in the I guess edge case where we go with two competing solutions, we need to sort of justify why. We're talking about, there's implementations and there's deployments of both or something. Maybe those are factors that would weigh into publishing both as well. So it's not as easy as just saying one document versus two. I think there's other things that need to be considered as well.
Thanks.
Thank you. No requests right now.
Then I think there is some more discussion needed. So I wanted to maybe another.
You'll take it? Yeah. Okay, so while we're packing things, why not pack asserts as well? It'd be interesting to get your opinions on this, whether this is something that would be a good idea or if it's crap, but we'd like to just get your opinions on this. And the goal is to be kind of forward thinking. It would be potentially helpful to reduce the sending and receiving of assert messages, the pressure of that, and maybe some, it's probably not really an issue today, but maybe in some future deployments, whether it's TSN kind of networks, there may be a benefit of doing this. We'll see. So actually, let me just explain it and then get your opinions. So we did include some use cases that describe where this could be helpful. And again, we admittedly need to develop these use cases more, especially ones that are maybe future related. But if we want PIM to scale well into the future, then we should be able to work on these kind of things. If we just want to push people towards beer and other things, then we won't. All right, so the problem that most of us are likely aware of is just the assert mechanism. If you do have a lot of sources and groups, there could be times where there could be, in short bursts, a lot of assert messaging that's happening. And there could be a large processing load on the routers. So we aren't proposing any changes to the PIM assert state machine. We are proposing a new PIM hello option extension for assert packing and being able to negotiate that packing capability. And then we're considering two types of solutions. One is a simple packing solution, and one a little bit more involved aggregating packing solution, if this is something that we pursue. So the proposed PIM hello option extension format is a new option type, and then a packing type, whether it's simple or aggregated. So again, the new defined hello option is used to negotiate the assert packing capability. And we will have a packing type of 1 for the simple packing type and a packing type of 2 for aggregating.
Stiger, I have a question. So if you support aggregating the type 2, aggregating them, do you then implicitly also support type 1 or?
I don't know.
Because if you support both, you announce 1 or 2, and what if some announce 1 and some announce 2?
Yeah, good question.
Are they discrete or a subset?
Yeah, we were assuming that they were discrete, but we need to make that clear in the draft. That's a very good point, Stig. Okay. Yeah, think about that one some more. So in the simple packing solution, you're simply taking the existing assert packet and inserting that into a new assert packet that's grouping all these asserts together. The original assert message bodies is used as the record, and it can carry multiple assert records, and then identify the number of records. So the advantage is that it's a simple extension. The disadvantage is that when you oftentimes have a small number of sources and groups, there could be a large number of records with the same metric preferences and stuff. So it kind of wastes the the payload or the transmitted message. But it is a simple way to go about doing it. And this is what the simple packet format would look like, just putting in those each asset record into the new packet. You could separately have a little bit more or a lot more involved aggregating packet solution where you could combine the records rated to the same source or RP address in the assert message. So in the case of like assert record 1, you could have the source address and all the groups that use that same address packed into that particular record. You can have another record which has, based upon the RP address, grouping the groups according to the RP address, and then subsequently each group record having the sources that use that particular group. More involved, not sure what hit that would have on the processing, but again, it's less messages that on the wire that the routers have to process. It adds more complexity. But the advantage is you're optimizing the payload of the transmitted message by merging the same field content. So I believe this is the last slide. This, again, just kind of takes a look at the PIM assert packing format on the left, upper left, and then each star comma G assert record format would be, you know, with the RP address and then all the different group records. The bottom left, you have a S comma G assert record and all the groups that use the same address, same source address, and then each group format would be as follows. So yeah, comments.
Yeah, tell us as a co-author. So I didn't have, you know, really a lot of cycles spent on trying to see all the details or so. My main interest was really the problems that we had with assert over the years. And so in business critical environments, like, you know, in the finance sector, what we had to do to deal with assert problems was really to tell them you can't have a transit LAN with multiple downstream and multiple upstreams. You need to create, you know, point-to-point LANs, and, you know, when your whole business depends on it, you can basically go through the trouble of changing your network. But since then, you know, another 10 years passed, and now we have a lot more interesting layer 2 technologies that actually, you know, you can buy Metro Ethernet LANs, right? If you buy a single Metro Ethernet LAN, that's a different price point than buying a lot more point-to-point Metro Ethernet LAN. Putting another Q and Q on top of it is another problem space. DetNet, you may get QoS in these LANs, right? So having the expectation that you don't have any transit layer 2 LANs just because of multicast, I think is a risky proposition for us, right? It's like in the Wi-Fi case, maybe kicking us as multicast more and more out of the picture, right? Now, obviously, the proof of the pudding would be to figure out if, you know, and I think that applies to the other packing draft as well, could there be any performance numbers, right? Some prototyping or so. That would really be, I think, very helpful to persuade, right? But obviously, it should be better. How much better, we don't know. And it's an important problem, especially because also in port, we have no replacement for the multicast asserts. So this thing is going here, the assert problem is going here to stay whenever you have multiple downstreams and at least, you know, 2 redundant upstreams. And so we should continue to be right, because in big deployments, we had big issues.
Thank you.
So if assert is becoming a scaling concern, I wonder if there are other ways to solve that problem without using P2P links. For example, you already, on a LAN, you already know who else is sending what kind of joins. If you remember that information, you maybe when you choose your own upstream router, you can consider who else is asking for that. Something like that.
So, I mean, that came up over and over again. I was always suggesting what I call strong RPF check, which is your RPF against the sending MAC address. And people were never kind of, you know, daring to break that layer separation, right? I think the guy back there is already starting to laugh out loud. So, yes, I think there are better solutions. No, I don't think we could get them through the IETF.
So that was Torla speaking, and it's Jeffrey speaking again for the people on video.
Another comment is that now if you start packing how long do you wait before you send out? And since this is for a certain, you're having duplicate packets going on, how fast, how quickly do you want to send out your SMS so that you can quickly stop the duplication? That's also
great questions. We aren't proposing any changes to the assert state machine, so that would all be the same as it would be today.
Not necessarily. I'm not talking about state machine change. I mean the timing, because when you are talking about packing, that means you're waiting for certain times before you send out your packets, right? That's what.
Yeah. Okay.
But typically, the way you do it is that you basically, as long as you don't have to wait, so you can read non-blocking, further assert notification in your control plane. That's when you basically take them, and as soon as basically your packet is full, there you send them out. That's no additional delay, right? That's no waiting for additional notification.
It's too hard to.
Mankamna Cisco. So I think actually Jeffrey asked my question. I just wanted to know that how are we going to implement it? How long you are going to wait when to send the update? Whether we will create list only for the subsequent asserts and we will send the new one right away, or how it is going to happen.
Okay, those are things we have not included in the draft. Thank you. Well, we should do that.
This is Dino. Yeah, those last 2 points are critically important in terms of implementation, because why do you send an assert? Because a packet came on an outgoing interface. That means at that point in time, there's only one S, G, and if you want to aggregate, that means you need to collect all subsequent S, G's that are going to come on this output interface. And if you wait, then Jeffrey's point is true that you're going to be sending duplicates while you're waiting on the previous ones. So it's really hard to implement, right? Okay. Now, so the other question I had is why do certs happen so much in sparse mode? Don't you send joins one way versus the other? So, or are you worried about the RPF case where you send the join to a new path and then the prune gets lost, so that guy still has the outgoing interface list, and then you have the double forwarding on a multi-access. So if you want to solve it for dense mode because the certs happen more often there, that's fine. But was that a motivation?
That wasn't. We were just thinking of sparse mode, just sparse mode, yeah.
In the transient case of joins, because a downstream router sends a join one way on a multi-access network to one neighbor. The only time I could think you get certs is when there's an RPF change, you join this way, and you didn't prune that way, which you should, the spec says you should, but if the prune gets lost, then you have two routers that are forwarding on the multi-access LAN, and that's when a cert would happen. But that doesn't happen very often.
No, it doesn't happen that often, and we do we do talk about that in the draft a bit. It's just that there could be those small bursts of times where there could be a lot in a short burst of time. It could be a lot of asserts happening if there's a lot of S sources.
So in that, okay, so what you're saying is in that transient case, there's a burst of asserts for a bunch of different S, G's that may have been affected by the prefix for the RPF chain.
Yeah.
And then how long do you think you should wait?
Because Turles may have some comments. I don't. Turles wants to.
The thing is,
some comments too.
If you wait for the timeout period, it's just going to clear itself out because the router's just going to prune. But that's going to be 3 minutes, and that's like infinity, right? If you wait 1 second, then it just doesn't seem to. I think it's going to be hard to do the implementation based on what these two guys said, and it doesn't seem like it's worth it for the very rare case. It's a lot of effort and machinery put in for a rare case. You believe it's a rare case, or you think it's going to happen more than that?
Yeah,
forward thinking, it may happen more. I don't know.
I'm gonna jump into the queue at some point too.
Yeah, well, get in there.
Along the same lines, why were asserts put in there? It was because of this idea that we would have transit LANs for multicast exchanges where one provider would pick this neighbor and another provider would pick a different neighbor. I don't know that we're going to have multicast exchanges anytime soon, and I think that use case may have evaporated. So maybe I think Dino's along the same, like on the right lines of the thing that we thought assert would do is probably irrelevant these days and moot. What is it? Yeah, for sparse mode and certainly for dense mode. If there's anything more moot, it would be dense mode. So I think it's worth looking at, all right, what does assert do now? Because asserts do happen. And is it just those transient reconvergence, or is it something's broken, or does it not happen that much? Because usually, what's your typical transit LAN? It's going to be a PIMZ with multiple PEs who have connectivity to the source. But again, are these I've seen asserts happen recently, but why are they happening? Is it because something's misconfigured? Is it because there's transient reconvergence issues? Certainly, I have a tough time believing that it's happening for the reasons we thought assert was going to be used originally. So I think that'd be worth looking at. Something's broken here. Somebody misconfigured something. Yeah, or somebody poorly designed something. It shouldn't happen.
That was Lenny from Juniper speaking, by the way. And Torlis is crawling out of his skin to say something.
Yeah. So first of all, in this thing, MBOND working group, we finished last year a BCP about interdomain. So there is basically a section about exactly that assert problem in exchanges, and you can't build these exchanges with a layer 2 LAN because you would get persistent asserts. So this is not the use case, right? This is the broken stuff. This is where we would need strong RPF check. This is really, in my opinion, for layer 2 transit LANs in normal enterprise networks, which may use Metro, which may use DetNet, which may use layer 2 subnets because transit instead of point-to-point for all the reasons that, layer 2 Ethernet has improved over the 10 years and is very attractive, except for the assert stuff, right? And we have seen in the past, as I said, exactly in these networks in finance, they were using layer 2 transit network. They had humongous refreshes, right? There is one improvement in the latest version of PIM, which is basically the proactive asserts. Oh, just because you're basically having not exactly the same type of convergence speed of your 10 downstream routers to your 2 upstream routers when you have RPF change, right? So when these two are conflicting with each other, both of them are sending, and you get the pretty much for all the state, the asserts is a standard mechanism. Yeah, the prunes and joins are overlapping, and basically the latest version of PIM has tried to improve that. And obviously one of the important things is to figure out how to implement it for the two cases. One is the data-triggered assert. The other one is a lot easier, which is the preventive asserts. And for the data-triggered asserts, I don't really see the issue, right? You have a queue of event notification. No, I mean, you basically get your assert, which are data-triggered events. There is a queue of that, and basically you're simply, whenever there is the first message in that queue, you look through the queue. If the queue has more than one element, you're just everything that's in the queue that fits into one assert packet, you're collecting and sending out. I don't see the problem, sorry.
ICE, Cisco. So I do want to support Torlis here on this first.
Did you say already say ICE, Cisco?
ICE, Cisco.
Yeah, okay.
So I would think, if you want to make modifications to asserts, it's better to get rid of them completely instead of trying to make it better. So RPF check based on MAC address or some other things, I think maybe that's where we should spend our time.
Revive it. Yeah. As a stake, I want to make some comments too. So I think one common case when you get asserts is last hop, where one router is a DR, but also another router is receiving a PIM join. So if you have both a transit LAN and a last hop, basically, or if they're receivers, then you will get asserts. And often asserts can be kind of transient situations, but once you get an assert, you end up sending asserts forever as long as you have SCOMA-G state. And for those periodic asserts, I think this draft is useful.
So this is Dino, based on what Torlis said about just make more of the layer 2 topologies point to point, does that mean there's multiple replications on that LAN? Because that's a disadvantage. You want to take advantage of multi-access LANs because you want the replication to be done by the media, not by the router.
Well, so I mean, read the BCP about the case of an exchange point where every downstream has different opinions who his upstream is, and he wouldn't like to get his multicast from a different upstream, right? So that's that case. Hopefully, that case should stay. Should have multiple copies. Exactly. So that case is out of bounds, right? That's what I was trying to say to Lenny, and I think we should basically have a sentence about that. That's clear. So yes, within a network where a single network operator wants to do the policies, obviously we should do the replication, but the whole point of strong RPF check is instead of very quickly for the transient case to try to resolve the duplicates and get rid of them, rather have a little bit more duplicates in the transient state and not do all the signaling.
The way to solve that is kind of like what ICE is saying, is you turn off asserts on that LAN altogether, and everybody who is switching over to joins, I know they do them at a different time, so some are still joining here until they get the RPF and stuff, but eventually they're all going to switch over, and there's going to be a shitload of prunes that are going to be going this way. So even if it's a congested network, one of those prunes are going to get through, and that's going to cause that guy to remove the OIF. So I think just get rid of the, I think, how about having a neighbor option to say we don't do asserts?
Right, but that's, I think, what we said, right? So the better option is strong RPF check, the way that's the term we phrased in the back. Well, that basically means both upstreams are for, half a seconds are sending, but when I'm sending my join, I'm putting in my RPF to say not only from this interface, but from the following sending MAC address. And that way, I will not forward duplicates. That's the whole point. You want to avoid that during the switchover, you're forwarding duplicates. And the asserts are all meant to avoid duplicates as quickly as possible. Yeah, that's exactly why, this is the best solution in my opinion, but people, we are not doing it. No, we haven't done it. Huh? Yes, that's why exactly.
Dino said that's a big change to products.
That's why I've given up on it. We've done it in MPLS, obviously, right? But you don't want to hear about MPLS, right? MLDP. Yeah, so the answer, of course, is MPLS, right? But if you don't want it, sorry, there's a cost for it. Either you try to optimize the assert, or you come up with another complex state machinery that everybody agrees, and, you make a downstream elector for everything, like an OSPF or...
This is ICE.
No,
ICE now.
Yeah. So I wasn't suggesting to stop using asserts. Well, yeah, stop doing asserts, but I think you need a strong RPF check, as Tula said. And strong RPF check means that downstream does not just RPF against interface, but something more. Now, I think we can be MAC address. You can use MPLS labels, or maybe even VLAN tag, or something to make your LAN into a virtual point-to-multipoint.
You don't want to do that. And if you use a MAC check, you're going to have to change all the chips. All the vendors have to change the chips.
I don't know how it is, but it's.
This is being recorded. You guys have to go to the mic. YouTube.
Just remove the assert, allow duplicates for a very short period of time, and everybody's roughly good. If you're running OSPF or any IGP, everybody's roughly going to converge at the same time and join the same way. So I think the amount of time that there's duplicates being sent is going to be minimized. That's the trade-off from sending a hell of a lot of asserts or waiting to aggregate them, which is still going to send duplicates. So,
Well, tell a second again, the problem with duplicates is that we have a lot of networks and video applications or so where duplicates, because they're causing link congestion, are a lot worse than, missing packets. Right, so and we're not getting missing packets because the switchover actually is fairly flawless in the way that we have it. It just creates duplicates. So
duplicates are happening anyways, right?
No. I mean, with the way we're working.
Yeah, you have to have an assert.
Right. Yeah. No. I'm saying if we had the strong RPF check, we would have pretty flawless failover, right? So that's.
I mean, that's fine. It sounds like an elegant solution, but I think it's super costly.
Right, but I mean, then that's fine. Which is basically why I've kind of.
Dino said it's super costly to vendors.
The MAC stuff, the strong RPF check. So that's the question: how cheap can it be made these days, right? And otherwise, here is a software-only implementation that optimizes the asserts. You're saying get rid of the asserts and accept duplicates. I don't think so.
Yeah, there are corner cases where you might end up with duplicates permanently, though. Like one example is, as I was saying, if you have transit LAN, there's also a last hop. If the DR is forwarding and another router is sending a PIM join across that LAN to receive the traffic, you might have.
But that's easier to fix because the outgoing interface was created by IGMP. You could do that check. That's easy.
Don't think it's that easy, but okay.
So. I think just letting duplets go is quite dangerous because you can have 10,000 states, right, converging. So it takes a while for PIM to converge, right? So the first prune you got in, okay, that duplicate got killed. But number 10,000, there's a lot of duplicates going on.
Yeah.
Don't forget, when there's a unicast RPF change, it's affecting a lot of S, Gs, and the joins are going to happen, and they're going to be aggregated and grouped. The prunes are going to get rid of a lot at one time because we already have an aggregated solution called join prune messages, right?
Yep.
It's just not one S, G like the assert has just one S, G.
Yeah, Lenny Giuliano, Juniper. So it seems like the choices are fix or replace asserts, which Dino's suggesting is really expensive. Nobody's ever going to do it. The alternative is don't bother doing asserts and just live with duplicates, because it shouldn't be a persistent duplicate case. Duplicates should be quite rare, and assert just shortens the amount of duplicates that you're getting. It doesn't eliminate it. And then what you're suggesting is let's optimize asserts. The idea of let's eliminate asserts only makes sense if you're not going to build asserts in the first place. But once you've already implemented asserts and asserts are there, you might as well keep them. It's not like somebody's going to go back in and say, let me turn off my asserts now. Perhaps there's a processing cost. Or maybe there isn't, and maybe the point of this was just to enhance the process, but the process is a rare and unlikely and not worth enhanceable process. I guess that's what it comes down to is, so yes, it would make sense if you were going to build an implementation to start. Like if you're going to implement PIM for the first time, let's not bother building this assert thing because I think it's obsolete. We don't really need it anymore. We'll just live with these duplicates, and it's a canary in the coal mine anyway, and you're broken anyhow if it's happening. Or you say this is a problem just for transient cases, in which case we're reducing it from a short amount of time to a shorter amount of time, or that. So I think. I don't know what I think, but that's.
I'm dying to know what you think.
I just what I would say is I'm not sure it's worth optimizing. I'm not sure it's worth fixing. I'm not sure it's worth eliminating. I guess I'm saying maybe we just stick with what we got.
Okay.
Put our hands up in the air and say,
Yeah, I think we have to stop pretty soon. That's a good summary.
I mean, we had nationwide DPT, right, which is basically these wonderful sub 50 millisecond layer 2 rings, which were basically carrying all TV programs of the bloody country. And, when you had to switch over between the two upstreams and you had 50 downstreams, right, you do get bloody asserts and you have duplicate traffic, to all the receivers, right? That is not a good service.
Thank you. We're going to be done there. Appreciate those comments. Those are very helpful. Us authors will powwow, and if anybody's interested in joining us in this, please do, and we'll decide whether we want to pursue it or not. Thank you.
Yeah, and if anyone wants to write some new drafts or proposals on how to do asserts differently or improve them or avoid them, whatever, I mean, you're welcome. It's a good discussion. And you bringing up asserts would be excite people and cause some discussion.
Thank you. So Home with Golgi Nokia. So first I'd like to thank the chairs for allowing us to present this here. I think this is a new multicast concept, and this being the PIM group, it would be nice for everybody to hear about it. It's a concept that we are working with Bell Canada and our Cisco colleagues, and basically what it is, it's a segmented routing policy for point to multipoint. So the basic idea behind this concept is that, as probably you guys know, going forward, there has been some changes on the unicast domain. Some simplification with segmented routing, the removal of MLD, the removal of MPLS protocols like LDP or SVPTE. Everything is being advertised with underlay IGP, overlay BGP, and then you have the PCE, which really calculates the traffic engineering and any updates to the path of a LSP throughout the domain. So those simplification, of course, starts trickling into the multicast domain as well. And this is the main idea behind this new concept. So basically what it is, it's a segment routing policy. It's instantiated on a PCE from a root to a set of leaves, and it gets downloaded from the PCE via different type of technologies, which I'll go through it later on, whether it's PCEP, whether it's BGP SRTE, et cetera, the PCE will download the tree to the nodes or the PCCs, and then the traffic will flow throughout that point-to-multipoint tunnel. Whether the point-to-multipoint tunnel is the PIMZ or whether it's sitting in the IGP and certain SG like IGMP, PIM joins will actually go through that tunnel. Beside the point, it's going to be like an MPLS tunnel on the data path that is instantiated via the PC. So I think I kind of explained this, but again, the SR replication is a point-to-multipoint segment. And if you guys are familiar with segment routing, a segment is presented via a label, hence the MPLS part of this. In the future, we might extend it to the SRv6, but as of now, it's MPLS. So you will configure the data path on the nodes via MPLS. There's going to be push actions. There's going to be swap actions on the data path. And there are two types of replication segments. There's a spray. Basically, what the spray is ingress replication, meaning that you try to create your tree via point-to-point segment routing tunnels. And then there's a tree seed. A tree seed is more like a tree, obviously, by the name. And what it means is there's going to be a root, there's going to be replication points, and there's going to be a leaf. The entire biggest point here to take is the tree itself is a single segment. So it's going to be presented via a single MPLS path and a single label stack. How that label stack going to be, if it's going to have extra pushes on, it comes on the PCE, which I'm going to explain later on. So you could have label stack with multiple labels on it when you try to do fast reroute. When your route is resolved via point-to-point segment routing tunnel, then you can start stacking labels. But as of now, the tree seed is a single segment. So the entire idea will take the Spring segment routing policy to the next step. So we are actually using that policy to create the point-to-multipoint segments. And it's really identified via a route and via a set of transit nodes and the leaf nodes. You can do traffic engineering. There could be constraints, colors, etc. And all those are done on the PCE. So basically, from the PCC point of view or node point of view, we will send the update to the PCE saying that this is the route. Here are a set of the leaves. On the next slide, you will see that. And this point-to-multipoint tree is identified throughout the network via the root node, IP address, loopback, whatever it is, and a tree ID, which is unique on that root node. So here's an example of it. Basically, this tree was instantiated via a single root and two leaves. And then the PCE was able to calculate the path throughout the network. So in this case, you can see that the PCE programs. So maybe I should take a step back. How it was instantiated on the root, in this case, could have been via two mechanisms. You could have gone on the controller and you could have said that here's my root, statically configure it, and here are my leaves. And then the PCE will actually figure out the path from the root to the leaf, figuring out what are the replication nodes. Or another way to do that is you could have used the next generation MVPN procedures with BGP, where you can discover your leaves via MVPN procedures. On the root, you will discover all the leaves via those procedures, and the roots update the controller with all that information. And that's how the controller will know where the root is and where the leaves is. Either way, it doesn't matter. The fact remains that the controller needs to understand a single root and multiple leaves to build that tree. So in this case, when the controller was really trying to build the tree, it realizes, as an example, from N1 to N3, there is an IGP shortcut, the example here. So what it does, it actually builds a label stack with that IGP shortcut on top of the tree seed, and we're going to have multiple label stacks. Or with the same token, between N3 and N5 in this example, there were two links. N3 could have created a fast reroute protecting the previous link, and that fast reroute, where it will be programmed from the PCE to the node, could have another label stack. So you could actually do label stacking via those mechanisms. From the node to the PCE, you could create a tree, you could delete a tree, and you can update the tree. Based on these procedures, PCE will recalculate the tree. If there is some optimization, the PCE can do make before break. So from redundancy, resiliency point of view, you're going to have redundancy and resiliency on the node itself, which is fast reroute, and you can recover the tree within minimum amount of time. But after that, like any other MPLS protocol out there, RSVPT, point-to-multipoint RSVPT, you could optimize the tree and re-download the tree to the PCCs or the nodes and do a make before break, whether that's local optimization, whether it's global tree optimization, and do a make before break to switch to a new optimized tree. So with the same token, there will be a couple of more drafts coming up. As I mentioned, we try to keep this concept very simple. The PCE is the brain of the concept. The PCE is the one that calculates the entire tree. As of now, IGP is not involved in calculating the tree, except the fact that the link states are sucked up to the PCE. There is going to be a PCE draft, which the SR policies are going to be defined. They are going to be based on like extra objects based on the current SR policy. There's going to be an MVPN draft, and the SR v6 tree seed hopefully will come soon. Go ahead.
This is Dino. A question on the PC. Can it compute reverse paths as well? There's no reason why it couldn't, right?
No, because the PCE really has the entire state of the network, right?
So decide if it's RPF or
exactly.
forward. Okay. And a suggestion, spray, it might be good to have another term, a different term, because people, rather than introducing new terms, people are going to say, is it like this or is it like that? Maybe you should call it head-end replication, because that's what it is. Okay. I mean, it's head-end replication of using regular segment routes. And for tree SID, that's probably as good as any other thing. I mean, replicating SID or whatever, but okay. But it just spray, and also spray gets scary because it looks like it's broadcast, right?
Actually, that's a good point. Thank you very much. Appreciate it.
There are indeed some discussions on the terms. I also agree that spray could be renamed to something else, but head-end replication versus ingress replication. The ingress replication is an established name. Yeah, it is in some context.
Yeah, the other reason I wanted to rename, and I forgot to bring up the point, is what you're really doing is you're replicating on the root. Some people call that ingress replication. Other people call it egress. That's another source of confusion.
Okay. Any other comments, questions? So I'm not going to go through the last slide. I think this is going to be part of the spring, from adaptation point of view, but thank you for your time. Thanks.
Who already saw this in MBondy? One, two. Okay, not too bad. Okay, so this is an update report of the work that started out something around IETF 102 about how can we update the status of our IGMP and MLD RFCs, with a particular fun data point that if you're looking for the best standardized full internet standard receiver signaling protocol, use IGMP version 1. That's in full internet standard. So obviously that's not what you want to do, but everything newer has just, draft or proposed standard. And so we wanted to change that. And so then we started to understand that we need to steal the process we did with PIM, which is basically trying to vet the industry operationally and implementation-wise, what's out there for the newer ones. And once we have that understanding, hopefully, then Alvaro tells us the next steps on how we can basically update the status of the documents, and maybe we need to fix the documents. But so right now we're at this questionnaire state. And so around IETF 103, we formed a mailing list and a group of people that started to work out that questionnaire. So there were a couple of really good meetings where we had all these people here, which are also now on the draft, come together and work out the questionnaire.
Just a comment, I'm not sure if it's in there, but the mailing list is archived and everything is public, so you can go and see it there. Yeah. And there's also a wiki and some stuff, right?
Yeah, wiki, really?
Yeah, if you go to the PIM wiki, there is a link to
the PIM wiki. Oh, yeah, I looked on the MBOND wiki. Yeah, okay, I'm confused. Right. So the plan would be to finalize this with basically the feedback. We got some feedback in MBOND. Hopefully we're getting feedback here as well. And please, if you can, bring it up on the list, ideally so that we're not losing it through the minutes. And once that's done, the plan as described in the draft is to have the PIM working group chairs, but maybe hopefully also anybody else who has an idea, try to start circulating with a request for feedback, that questionnaire to, vendors and operators. So, I mean, the obvious one is Internet 2 mailing list, right? There's Internet 2 multicast. Hopefully we'll remember all similar mailing lists in other parts of the world. Or, specifically address and send it to operators that we know in the IETF, right? Just sending it to PIM or MBOND will not have as much an effect as sending it out to the individual operators we all know here. And then the process would be to designate a trusted party that collects the feedback and anonymizes it. And so the proposal here was Tim Chown. I guess that's something to finalize by the working group chairs and put in the final questionnaire.
Yeah, so Tim Chown did this for PIM sparse mode, and I have briefly talked to him, and I think he's okay doing it.
That would be great,
yes. Later. One thing though, I see, like we discussed in MBOND, the draft name here.
On this slide is still, sorry, I was totally backlogged. On the next slide is corrected. So
so there is a draft that we need to consider later whether we should adopt it or not. But I guess
it doesn't really matter that much, right? If we want to just on data tracker, finalize it for eternity, we can as well adopt it once we're done with everything so that it gets posted. But I mean, having an RFC isn't, much different from being able to send around the draft, right?
Right. So, so we can discuss that later whether we need to
finalize. Hopefully we're getting that done before 105, right? So that we get through the process, and then the story continues from there on. So can you click there? I can't click. Click. Yeah. Let's see. In the past, this has shown to work. Can you maybe get out of full screen because it may have.
Share the browser.
Yep. Okay. Oh, right. It did work. So we skip the IETF yada yada. Then the introduction is kind of for the target audience, the yada yada, why we're doing this. I think we explained this. And then basically we're starting here with the intended audience, and we've basically cut the questions, were replicated then and slightly made them different between operators and vendors. So let's go down. Obviously, here the first one is for implementers. A lot of the questions are duplicated, but we wanted to make sure that people don't get confused. and so we duplicate it between operators and vendors. So here's the implementation status questions, right? IGMP v1, v2, v3, also very important, IGMP v3 Lite. So one of the interesting outcomes, obviously, in the end would be, can we identify from the feedback enough justification whether to make IGMP v3 Lite or full IGMP v3 the final best recommended standard? Same thing for MLDV1, MLDV2. So, and then go further down. So these are a little bit open-ended question because we felt a little bit that overwhelming customers with details would be too much. In MBOND, we got the feedback that we may want to give an example list of features just as hints. And I think that's one of the things we're going to do. Then very similar, go down to 3, implementation perspective, questionnaire. That's, yeah, right. So this is also, yeah, it would be lovely to get feedback on this implementation perspective. That's also a little bit open-ended because we're trying to really compress the thing and not come up with a lot of detailed questions, but obviously that is always difficult to do. Then going down, 3.2, deployment status. So this is, you can go down faster here, right? So you saw this was copy and paste, and we forgot one implementer, so it should be all deployed because this is for the operators. Deployment specifics, very similar, just, you know, are they deployed? And yeah, also the type of open-ended questions. So yeah, we'd love to get any further insight, and we're also within the team are going to go back and revisit the latest state here. The one other feedback which I found to be helpful from Mikael Abramson was the bitching about the problem that in IPTV deployments, he wanted to have SSM, and then ultimately he got the answer, yeah, we're doing IGMP v3, which just meant the setup box operating system supported IGMP v3, but the application was just sending an IGMP group membership report. So the application effectively didn't use SSM. So, and my proposal was that we do add a section there, application, and asking basically if applications that should use, you know, SSM are not using SSM or something like that. It's clearly somewhat outside of the original scope, which was just for PIM to understand the status of the RFCs that we should get, because this would be an application question. But I think for us in MBOND and also trying to figure out how to deal with this problem that, you know, IGMP v3 support by the OS is not good enough. The application also needs to do SSM. How we can basically in the future try to, you know, highlight that as an issue better. So that was a suggestion to add a section on that with, you know, 1 or 2 very simple questions. And yeah, go to the end. I think that was pretty much it. Yep. Please read, and who has read it here? Good. Who has already posted comments? Yeah. Please post some comments to it on the mailing list, right? So so that we, you know, get really that insight. Yeah. Any questions here?
One question that was raised is, how do we reach out to the people that need to respond to this? So there's like vendors that go to the IETF, but there might be like host stack vendors that are not here at the IETF. And of course, there's things like Nanog or Ripe or Internet2 or communities. But
I mean, there are a lot of people that, you know, have connections to these folks. I mean, we can try to figure out when we are at that point how we can split it up so that the poor folks, let's say from Microsoft or from Google or Linux folks, don't get overloaded. But I think we can come up with some good list and have multiple of us divide that up.
Yeah, Tim Winters from the UNHI. Well, you know, we have a lot of people who do testing for MLD and IGMP at our lab. In particular, we do have a lot of MLD because of the U.S. government test profile. We'd obviously send this to all of those hosts and routing vendors to try to get them to respond.
Excellent. Good. We're done. Thank you.
yeah, thanks.
Yeah, I wish go on to, no, we need
Yeah. Well, a start discussion was certainly good. But I wanna, have some feedback on the draft. I guess I can do it on the mailing list. Yeah. No, one concept. Yeah. No, I think it's very useful. We have seen lots of issues with asserts, and I also don't think it's an issue with timing if you do this just with periodic asserts. Yeah. But we can discuss that. Yeah. No, there's some prototype code that Cisco for MTrace too. And Cisco has some prototype code for MTrace version 2 at least.
Because MTrace board is right in the middle of the Linux version.
Oh, really?
Yeah, so we implemented it, we run our test scripts, and boom, Linux board. Yeah.
Oh. I didn't realize that.
So, to the working group. Yeah. And I haven't done this response for it. I think it's
doesn't Traceroute has like an assigned or
no, it's the range. So for it goes to the first port and it suddenly sends the second packet to the TTL to the second port. That's how it tracks.
Yeah.
So,
but that range is not assigned or.
Maybe it's not, I don't know. All I know is that we are on the second port. Okay. Like MTrace 2, Z2 is right on the second port.
Yeah, I can try to look into it as well. I mean, I'm curious about other assignments as well, right?
Yeah.
You ever come across other ports in that range?
I think if you implement it, doesn't matter you or us.
Yeah, sure.
We're gonna break Linux.
Yeah.
Linux has rest forever, right?
Yeah, sure.
Not us, well, not MTrace.
Yeah. No, I guess we haven't tested it that much, but we need to look into that. Yeah.
All right, sounds good. Let me know what
okay, sure. Yeah,
Thanks.
Yeah, that's good. We have to check, what they use and whether the IANA assignment is correct or I wonder, if no one cares. Should be an issue for other applications too that got those ports in that range. Oh well. Yeah, I need to. I haven't seen the email on my list, but I have to look for it.
Yeah. So.
Yeah. I mean, I think based on they were explaining a few IETFs like how first level conflict was like, maybe the same person was chairing 2 groups or something. And the second was like pretty strict as well. So I think based on those